Words translated to symbols with exponents or powers. Another word for exponents is powers. All right. So here we did 1, 2, 3, raising up to the exponent of powers. That's multiplying any value by itself. So please get out your pencils, your pen, and your paper, and you can start practicing. You can, instead of 3, you can use 4. You can use 5 to practice this, raising up to the power exponent. Here we are going to demonstrate how these words can be translated to symbolic form with an example. Now it says now ax raised to the exponent, ax raised to the exponent of power of n times bx raised to the exponent of m is a times b times x raised to the exponent of power of n plus m. So that's a mouthful. Let's go over that again. Now, ax raised to the exponent of power of n times bx raised to the exponent of power of m. Okay, so let us translate that symbolically. Ax we're going to write ax, okay? Ax raised to the power of n, or exponent of n. So as you can see, it's only x that is being raised to the power or exponent of n. Okay. So be very mindful of that. It's only the letter x that is being raised to the power of n. Actually, the power of a there is actually 1. If you don't see an exponent, it's an exponent of 1. So you can write bare a, or you can write a to the exponent of 1. You don't normally see raised to the exponent of 1. Okay, but just be mindful. If you don't see an exponent or power, there's the power is 1. So if x alone has been raised to n. Times bx times bx. So you can actually see the translation happening. Raised to the power of m. And it's only x again that's been raised to the power of m. B has a power of 1. B has an exponent of 1. We can interchange between the word power and exponent, bear that in mind. All right. Is a times b, a times b. Now, if you see 2 letters next to each other, the operation that is between them is times automatically. So a times b can be written as ab. So is a times b times x raised to the power of n plus m. So in a nutshell, when the base is the same, remember we know that's the base already, and this a is the coefficient and the power of n. When the base is the same and you are multiplying, you can add the powers. So it's only when you are multiplying and for the same base, then you can add the powers. Okay, take note of that. For example, let's say you have 4. Now the base don't necessarily have to be n. It could be x, or it could be y. It could be any letter. Let's say you have 4y times 5, I have to, for me to make an example like that, I must use the same y again. Now I have to give, well, if you don't see a power, an exponent, the exponent is actually 1. Okay, so here n would be 1 and m would be 1. You have to multiply 4 by 5. It says AB, so 4 5s are 20. You have to multiply the coefficients, and the letter now, the base now, you have to raise it up to the addition of the powers. The powers, if you don't see one, if you don't see any power, it's 1. All right, if you don't see any exponents, it's 1. So there's an invisible 1 above the y, there's an invisible 1 above the y. That's where that 1 plus 1 come out from. And then 1 plus 1 will give us 2. If we want, we can actually put the 4 times 5 here, just to show that intermediate working. 4 times 5, 4 times 5, instead of just putting 20, y raised up to the 1 plus the 1, if I have to show all working, and this will simplify to 20 y raised to the 2. Okay, let's do another example. Let's say we have 3, okay, x raised to the power of 6, for example, times, must be times for this rule to work, 2x raised to the power of 4 equal, so we have to multiply 3 by 2, 3 2s will give us 6, and x now, we have to add the powers raised to the power of 10. 6 plus 4 is 10. Okay, now let's go to example number 5. Now, ax raised to the exponent or power of n divided by bx raised to the power or exponent of m is a divided by b times x raised to the exponent or power of n minus m. So here we're talking about divide now. Divide is like the inverse of multiplication, and we're talking about subtraction instead of division. So now we have ax, the same ax raised to the power or exponent of n. Here we have it. We have it there, so we can just copy it. Ax raised to the power or exponent of n divided. So we have to put, instead of multiplication, we are doing division now. Bx raised to the power of m, and notice that it's only x alone that is being raised to the power of m and n, okay, is equal to a divided by b, because it's division we're talking about now. So it's a divided by b times x raised to the power of n minus m. Okay, so n comes first because n is the divisor, m is the dividend. M is the dividend, n is the divisor. It's n divided by m, so you have to be n minus m. Okay, if it was m divided by n, if it was m divided by n, then it would have been m minus n. Okay, but since it's n divided by m, it's n minus m. One example of this, for example, would be, let us say you have, here we can use that very same example. 4x, 4y, instead of times, we're going to put a divide. (4y) divided by 5y. So A would be 4 and B would be 5. Okay, N and M would be 1 and 1 respectively. So that would be like 4 divided by 5 times y raised to the power of 1 minus 1. Bear in mind, there is an invisible 1 above the y. Now, 1 minus 1 is 0. All right. 1 minus 1 is 0, but y divided by 5 is y divided by y is 1. 4 divided by 4 is 1. 6 divided by 6 is 1. A divided by A is 1. Y divided by Y is 1. So this is a little subtle proof that any quantity raised to the power of 0 is 1. So y raised to the power of 1 is actually 1. Y raised to the power of 0 is actually 1. So that simplifies to 4 over y. So just remember, any quantity raised to the power of 0 is 1. So we have two rules happening inside there one time. The division rule, where you have to subtract the exponents, and any quantity raised to the power of 0 is 1, because y divided by y is 1. So y raised to the power of 0 is actually 1. Actually, you can even see any power raised to the 0 means that it signifies it being divided by itself. Okay, so just remember the multiplication rule. You add the powers, the base have to be the same, and you multiply the coefficients. The division rule, you divide the coefficients, but you have to subtract the powers, and any quantity raised to the power of 0 is 1.